Today we're going to learn all about the standard form of a quadratic equation. Something is considered a quadratic if it has x squared, x to the second power in the equation. When we're looking at a quadratic, a graph of a quadratic, what we're looking at is called a parabola. That is the shape you see, a parabola. There's a couple of key features we want to talk about. The first of which is called the axis of symmetry. That's the line you see in yellow. That is simply the line that divides a parabola in half. And there's two ways we can calculate this. One, if it's already graphed, we can just look at the graph. In this case, my axis of symmetry is x equals -2 because it crosses the x-axis at -2. But our second way is to use the axis of symmetry formula, which is -1 times b all over 2 times a. So let's actually pull out what that means. If you look at the standard form of a quadratic, you'll see the coefficients are called a, b, and c. Let's go ahead and pull out what my A, B, and C are. So if we look at our formula for this graph, looks like my A value is 1, my B is 4, and my C is 3. So let's plug these into the formula. -1 times 4, 2 times 1, so I can see that my axis of symmetry, when I calculate it using the formula, is still x equals -2. Another key feature we want to find is in red, and it's called the vertex or turning point. You'll hear it referred to both ways. If you'll notice, the vertex always sits on the axis of symmetry. So we already know the x value for our vertex. The x value for our vertex is -2. There's two ways that we can calculate our vertex. One, we can look at the graph and read the ordered pair. Or if we're not given a graph, we take the axis of symmetry and plug it into the original formula. So I'm going to grab the original equation, substitute in my axis of symmetry, and calculate my y value. Either way, we're going to get the same answer, that we have a vertex or turning point at -2, -1. What you see highlighted in green is something called the x-intercepts. These are also referred to as the zeros, the roots, or the solutions. You'll hear these words used interchangeably. So again, there's multiple ways to find this answer. One is just look at the graph, and we see we have one x-intercept here and another one right here. So we'll write these ordered pairs as -3, 0, and -1, 0. We'll learn the other methods for finding our x-intercepts, zeros, roots, or solutions as we progress throughout the unit. Our last key feature is in purple, and that's the y-intercept. That's where my graph intersects with the y-axis. And so there's, again, two ways we can find that. One, we can look at the graph and see we have a y-intercept at 0, 3, or we can plug in a 0 for x because our y-intercept is always at x equals 0. So I'm going to plug a 0 into the equation. And see that I get a y-intercept, a y value of 3, so my y-intercept is 0, 3. Let's review some of the tools that we just learned. To find the axis of symmetry, you can use the formula x equals -1 times b divided by 2 times a, or you can graph it. To find the vertex or the turning point, you can plug that axis of symmetry into the original equation to get your y value, or you can graph it. To find the zeros, roots, x-intercepts, or solutions, you can graph it. We'll learn the 2 other methods as we progress throughout the unit. And to find the y-intercept, you can graph it or substitute x equals 0 into the original equation.